Hello, everybody. In today's mini lesson, we are going to start talking about end behavior. So grab your math notebooks and let's hop into it. Our essential question for this mini lesson will be, how can I represent the end behavior of continuous functions using the proper mathematical notation? So my goal of this is we're first going to start off just describing the end behavior in words, starting off slow, easy to get a grasp of what's happening, and then slowly progress and use the proper mathematical notation. So let's hop into it. End behavior, what is it? It's one of our key features of our functions. Just like an x or y intercept is a key feature, identifying the domain and range is a key feature, identifying intervals where a function is increasing or decreasing, end behavior is a key feature of our function. And end behavior describes the height of our function on the left and on the right, aka where is our graph going? Is it pointing up? Is it pointing down? How high is it pointing up and how low? Or is it approaching something else? So really, at the end of the day, we have three possibilities. Our graph can point upwards, our graph can point down, or our graph can approach a constant. For example, here's just like a random little graph that I'm going to throw out there. This might be a function that we're studying. On the left, it's pointing down, and on the right, it's pointing up. That's essentially what end behavior is, but in fancy mathematical notation. Or maybe we have a function that kind of looks like this. On the left, this function is pointing up, and on the right, this guy's kind of flattening out towards a constant value, and we'd have to look at the height of our graph to see where exactly that is. So let's just start by observing a couple graphs. This first graph kind of looks like the shape of a W, and if we were to describe the end behavior on the left, so as we're moving x in the left direction from 0, where's our function pointing? And since our function is pointing upwards, it has an upwards arrow, we would say that the left end behavior is pointing up. On the right, we're going to start at x is 0 and move towards the right. And since our graph is still pointing up, we would say that our end behavior on the right is also pointing up. Not too bad, right? Let's see if you can describe the left end behavior and the right end behavior of the next picture, our next function. Here it is. All right, so the left end behavior, as we start as x is equal 0, and we move towards the left, we just want to look and say, how high or how low is this function going? On the left, since it's pointing in the downwards direction, we would say our left end behavior is pointing down. And on the right, starting at x is 0 and continuing towards the positive right direction, we can see that our graph is also pointing down. So the right end behavior is saying as we move to the right, the function is pointing down. Hopefully you're like, hey, this is not bad. I think I can handle this. Let's see if you can determine the end behavior of the next function. All right, so here we have one which is going in opposite directions, and that's A-okay, nothing we can't handle. The left end behavior is starting at 0 and moving towards the left, and on the left, my function is pointing down. It is pointing down on the left. As we move and progress to the right, though, my function is pointing up. And lastly, on the left, this function's behavior on the left. As I move to the left, my function is pointing up. And as I move to the right, my function is pointing down. Of course, end behavior isn't exactly this easy, but really, it's just describing where's our function going. Is it going up? Is it going down? Is it approaching a number? What's happening? And we're going to start to introduce that fancy mathematical notation. So here's the notation, and trust me, it feels scary, but I promise it is not. So the left end behavior, remember, as we were moving to the left for all of our functions, we were going kind of like this way. We were moving to the left on our x-axis. And really, the left end behavior is just going to say, As x approaches negative infinity, because that's the smallest number, the smallest x value, we want to know what's the function approaching. And we have three options. We have the option of positive infinity, which means our graph is pointing up. We have the possibility of our function is going towards negative infinity. That means our graph is pointing down. And we can have our graph approaching a number if it's kind of flattening out, if our graph is getting flat. And the notation that accompanies this is x arrow negative infinity, y arrow, and then we essentially fill in the blank. So as we are reading, as x approaches negative infinity, that just means we're moving in this direction, reading it from the left specifically. X arrow negative infinity, that's exactly what that means. That just means the left side. As we go to the left, our function, y, is going where? And we're filling in this blank right here based on if our function is pointing up or down or if it's flattening out. Similarly, for the right end behavior, was as we were trucking along and moving towards the right. So we started at 0, and as we moved in this direction, we wanted to know what was happening. So similarly, as x approaches positive infinity, that's just describing moving to the right. And again, as it's moving that way, we want to know where's the function going. So the notation looks pretty similar. We have as the function moves to the right, as x approaches positive infinity, we want to know how high or how low. We want to know where is our function y, where is it going? And again, we're just going to fill in this blank with either positive infinity if it's pointing upwards, negative infinity if it's pointing down, or a number if it's kind of flattening out on the right. So the left end behavior will always have negative infinity, and the right end behavior will always have positive infinity next to the x. Let's jump into an example and start describing it in words, but then also using our fancy mathematical notation so you can kind of see what we mean. Okay, here are two functions. I want us to describe the functions and behavior from left to right in words, and then I want to see if we can use the proper notation and start to make some connections. I'm going to label the one on the left function or graph number 1, and the one on the right function or graph number 2. And if we were going to describe the end behavior of this function in words for function number 1, we would say that on the left, the function is pointing down. Pointing down. And if I was going to use the proper notation, I would say that as x approaches negative infinity, y approaches negative infinity. And this really just means that on the left, as x approaches negative infinity, I want to know where's my function going. It's pointing down towards negative infinity. And if I were to describe the right end behavior, on the right, my function is also pointing down. So to use the proper notation, I'm going to say that as x approaches positive infinity, my function is pointing down towards negative infinity. And again, on the right, wrong color. On the right just means that as x approaches positive infinity, right? That's this side of the graph. I want to know where's my function headed, and it's pointing down towards negative infinity. Let's see if we can do it with graph number 2. I encourage you to describe the left end behavior in words and see if you can come up with the proper notation. All right, let's check it out in words. If we were going to describe the left end behavior of this function, and we can see that it's pointing up. So on the left, our function is pointing up. That is the end behavior in words. Using our fancy mathematical notation, the left end behavior says as x approaches negative infinity, our function points up towards positive infinity. So on the left, as we're moving towards the left, x approaches negative infinity, and we want to know, where's it going? It's pointing up towards positive infinity. It's going in the up direction towards positive infinity for the y value. Cool. And if we were going to describe the right end behavior for function number 2, the function on the right is also pointing up. So using our fancy mathematical notation, we would say on the right, or as x approaches positive infinity, my function is going closer and closer to positive infinity again. So on the right, as we're moving this direction in the right, as x is getting towards positive infinity, I want to know how high or how low is my graph going. My graph is pointing upwards, and up can be replaced with positive infinity. Let's do some more. Hopefully you're realizing like, hey, that's not so bad. Here is our fancy notation. Again, the left end behavior is always moving to the left. It's always x approaches negative infinity. The left end behavior is always going in that direction. It's always approaching negative infinity. And I always want to know, like, where's my function going? Here it's pointing down, we have negative infinity. Here it's pointing up, we have positive infinity. On the right, we're moving towards x is going to positive infinity. Think of on the x-axis, we're going towards positive infinity, right? Same thing over here. We're going towards positive infinity. That's why the right notation has x arrow infinity. We still want to know how high or how low. And this guy, he's going down, so we're going down to negative infinity. This guy, he's going up. We're going up towards positive infinity. Here's a function. Describe the end behavior and use the proper notation. I challenge you to see if you can do it on your own. All right, so on the left, our function is pointing down. Our function is pointing down over here on the left. So my notation would say as x approaches negative infinity, my function's height is going down towards negative infinity as well. On the left, on the left, as we move towards negative infinity, my function's height was going towards negative infinity as well because it was pointing down. And on the right, my right end behavior, as my function is moving towards the right, my graph is pointing upwards. So using my fancy math terminology, I can say as x goes towards positive infinity, aka the right, my function is going towards positive infinity, aka it's moving in the upwards direction. So as we move along this way towards positive infinity, where's my function heading? Well, you know what? It's going up. It's going towards positive infinity. And here's your last two examples. See if you can just use the notation. try to see if you can just use the notation and double check if your description is correct. We'll start with the one on the left. So for the functions and behavior for the function on the left, function number 1, on the left, our function is pointing up. So as x approaches negative infinity, our graph y is going towards positive infinity. And on the right, it's pointing down. So my notation is going to say as x goes to the right towards positive infinity, my y value is pointing down towards negative infinity. So on the left, on the left, as we move towards negative infinity, my graph is pointing up, so we have positive infinity. On the right, as we go to the right, as x goes to positive infinity, my function is pointing down towards negative infinity. What about function number 2? Function number 2, this line over here. Our end behavior on the left, our function on the left is going down. So as x approaches negative infinity, our function is going, our y value, our height is going towards negative infinity. On the right, our function is pointing up. So as x goes towards the positive values of x, positive infinity, our vertical height is going up and up and up towards positive infinity as well. Again, as we moved to the left, as x went to negative infinity, I wanted to know where my function's going. It's going down, so y is going to negative infinity. As we moved to the right, as x went to positive infinity, we still wanted to know how high or how low are we going? And we're going all the way up. We're going towards positive infinity.